Let's begin with the most offensive fact astronomy ever delivered to human ego. We thought we were studying the universe. Turns out we've mostly been studying the cosmic equivalent of foam on a cappuccino. For centuries, humans looked up and assumed the glowing stuff was the main stuff. Reasonable mistake. Stars are dramatic, nebulae look like God hired an artist, galaxies swirl like divine fingerprints. But when scientists began measuring how galaxies actually move, something strange happened. The math stopped behaving. And when the math starts acting weird, scientists do one of two things: panic quietly, or invent a new particle and give it a cool name. In this case, the universe seemed to be hiding mass, a lot of it. Not a little oops dropped a decimal amount, a staggering, structure-holding, galaxy-shaping amount. So let's break the cosmic pie into slices. About 5% ordinary matter, everything made of atoms, stars, planets, dust, people, tacos. About 27% dark matter, invisible matter that seems to have gravity but doesn't emit light. About 68% dark energy, the even stranger thing driving the accelerated expansion of the universe. That means when people say 95% of the universe is unknown, they're talking about the combined mystery of dark matter and dark energy. And today, our main suspect is dark matter. Because dark energy is mysterious, but dark matter is personal. Dark matter reaches into galaxies, into motion, into cosmic architecture. It's the invisible scaffolding of the universe. The clue that broke the case open. Now, let me tell you where the trail begins. Imagine children on a merry-go-round. If the ride spins faster, the outer kids need a stronger grip, or they go flying off into the moral lessons section of history. Same with planets orbiting stars. Same with stars orbiting the center of galaxies. The farther something is from the center, the weaker gravity should become, unless there's enough mass holding it in. So, astronomers measured how fast stars move around galaxies, and what they expected was this: stars near the center, fast; stars farther out, slower. That's what normal gravity predicts, if most of the mass is where the visible light is. But that's not what they saw. Instead, stars far from the galactic center were moving way too fast. Not a bit surprising fast, not, interesting fast. If our equations are right, these galaxies should be flying apart fast. And yet, they weren't. Something unseen was adding extra gravity, something massive, something spread throughout and around galaxies, not glowing, not reflecting, not interacting with light the way ordinary matter does. In other words, dark matter. This is one of the strongest reasons scientists believe dark matter is real. We don't just like the idea, we infer it because gravity keeps betraying its presence. You can't see the culprit, but you can see the furniture moving. Enter the detectives. This is where the story gets beautiful. Astronomy became detective work. Scientists started gathering clues from multiple crime scenes across the cosmos. Clue number 1, galaxy rotation curves. Galaxies spin as if they contain far more mass than we can see. Clue number 2, galaxy clusters. Entire clusters of galaxies move as though an enormous amount of hidden mass is binding them together. Clue number 3, gravitational lensing. Sometimes light from distant objects bends around invisible mass, like a cosmic magnifying glass. The light is telling us there's something here, even when telescopes show nothing glowing there. Clue number 4, the cosmic microwave background. The oldest light in the universe preserves patterns that fit a cosmos containing a large, non-luminous matter component. So dark matter isn't hanging on one shaky idea. It's supported by multiple independent lines of evidence. And that matters, because in science, one clue is gossip, 4 clues is a case file. What dark matter is not. Now, let's clear out the nonsense before the internet arrives wearing sunglasses indoors. Dark matter is not regular matter hiding in the dark. giant clouds of invisible dust, black paint on the universe, just black holes as a full explanation, or proof that your missing car keys entered another dimension. Dark matter is called dark because it doesn't seem to emit, absorb, or reflect light the normal ways matter does. That means telescopes can't just snap a selfie of it, but gravity absolutely knows it's there. Dark matter appears to interact strongly with the universe through gravity, while being frustratingly shy about almost everything else. And honestly, if the universe was a person, this would be exactly its personality. Show up everywhere, explain nothing, leave clues, refuse interviews. The rabbit hole gets deeper. Now, here's where the mystery gets delicious. If dark matter is real, what is it actually made of? And the honest answer is, we do not know yet. That's not failure, that's frontier. Scientists have proposed candidates for decades. WIMPs, weakly massive particles, a longtime favorite, heavy particles that barely interact with normal matter. Axions, hypothetical ultralight particles that could solve multiple physics puzzles at once. Sterile neutrinos, a more elusive cousin of known neutrinos, and other exotic possibilities beyond the standard model of particle physics. And here's the twist. We've built experiments specifically to find these things. Deep underground detectors, sensitive instruments shielded from cosmic noise, particle collider searches, astrophysical surveys mapping the invisible mass of the cosmos. Humanity has essentially said, if the universe won't introduce us politely, we will search its basement. And still, no confirmed direct detection. That's what makes this so thrilling. Dark matter is not a solved chapter. It is an active investigation. Why this matters to you? At this point, someone in the comments is already typing, "Cool story, but I still have rent." Fair. But this matters because dark matter may be the reason the universe looks the way it does. Without enough invisible mass early on, galaxies may not have formed the way they did. The large-scale cosmic web, the vast structure of the universe, would be different. The night sky itself might not look like this. That means dark matter may be part of the reason stars gathered, galaxies held together, and cosmic structure had enough gravitational backbone to become everything we now observe. So this is not a side quest. This is architecture. You are living in a universe whose visible beauty may depend on an invisible framework. That idea alone should humble every human being who has ever said, "I only believe what I can see." Friend, your own galaxy disagrees. The dark energy twist. Now, let's go one layer deeper. Remember, dark matter is only part of the 95%. The bigger slice is dark energy, about 68%. If dark matter acts like cosmic glue, helping gravity hold structure together, dark energy acts more like cosmic anti-glue. It's the name scientists give to whatever is causing the expansion of the universe to accelerate. Not just expand, accelerate. That means on the largest scales, the cosmos is not merely stretching, it is speeding up as it stretches. So, in the same universe, we have an invisible mass helping hold things together, and an even more mysterious force driving space apart faster over time. That's not a simple universe. That's a universe with layers. A universe whose visible surface hides deeper rules. And suddenly, we understand reality starts to sound a little ambitious. The human lesson. This is where science becomes philosophy without asking permission, because the dark matter mystery teaches us something profound. Reality is not limited to what your eyes can detect. The most important structures in existence may be invisible at first glance, not because they aren't real, but because reality is under no obligation to be obvious. That is true in cosmology. That is true in history. That is true in human life. Gravity is invisible. Magnetic fields are invisible. Radio waves are invisible. Your Wi-Fi is invisible, and yet somehow still weak exactly when you need it most. The point is simple. Unseen does not mean unreal, and the universe keeps repeating that lesson, from atoms to fields
to space-time, to dark matter itself. Conclusion. So, what is 95% of the universe? By our best current understanding, about 27% is dark matter, unseen mass shaping galaxies with gravity. About 68% is dark energy, the unknown driver of accelerated cosmic expansion, leaving only about 5% for everything we've ever touched, built, eaten, feared, loved, launched, or complained about online. That means the stars are not the full story. They are the glitter on the blueprint. And the great cosmic joke may be this: humanity looked into the heavens and thought, we are finally learning what everything is made of. And the universe, with ancient calm, replied, you've identified the garnish. So, the next time you look at the night sky, remember, you are not just
staring at stars. You are staring at a mystery. A visible world suspended inside an invisible empire of mass and force that we are only beginning to understand. And maybe that's the real wonder. Not that we have solved the universe, but that we have learned enough to realize how much remains hidden. If you want more videos that turn the biggest mysteries in science into stories you can actually feel, subscribe.